You know, to feed a growing global population, plants need way more than just a bit of sunlight and water. They need a specific chemical diet. Today, we're going to dive into the incredible science of fertilizers, the chemistry that literally turns barren soil into these bountiful harvests.
Okay, so let's get right into it. Before we talk about the solution, we've really got to understand the problem. And that problem, it starts right under our feet, in the soil itself.
Think about it. Every single time we harvest crops, we're not just pulling up a plant, we're yanking out all the nutrients it soaked up from the ground. And modern agriculture is so good, so efficient, that it strips these essential minerals out of the soil way faster than nature can put them back. This creates a huge nutrient gap, and you end up with weaker, less productive plants. I mean, you can just see the difference, can't you? Healthy versus nutrient-starved. It's night and day.
Now, this right here, this is the single most important rule in all of fertilizer chemistry. A plant could be sitting in a pile of nutrients, but if they aren't dissolved in water, they are completely 100% useless. They have to be soluble, so they can be absorbed as ions through the plant's roots. This one concept is absolutely crucial, and it dictates everything else we're about to talk about.
So if we need to put nutrients back into the soil, which ones matter most? Well, that brings us to the three heroes of our story: N, P, and K.
You have definitely seen these letters on bags of fertilizer: N, P, and K. They stand for nitrogen, phosphorus, and potassium, and they are the absolute vital trinity for plant life. This diagram does a fantastic job showing how each one has its own special assignment, targeting a different part of the plant to make sure the whole thing is healthy.
Let's break that down a bit. Nitrogen, that's all about growth and getting that deep green color. It's a key part of chlorophyll and proteins, giving you those lush leaves. Phosphorus is the power provider. It's essential for building strong roots and managing the plant's energy. And potassium? Think of it as the plant's regulator. It manages water and helps flowers and fruits develop correctly, all while helping fight off disease. A complete fertilizer has all three of them.
Okay, so where do we get this stuff? Let's start with nitrogen. I mean, it makes up about 78% of the air we breathe. So the challenge isn't finding it, it's catching it and turning it into something a plant can actually use.
And this is how we do it: the Haber process. It's honestly one of the most important industrial inventions in history. It takes that super unreactive nitrogen from the air, and using insane amounts of heat, pressure, and an iron catalyst, it forces it to react with hydrogen. And the result? Ammonia, the starting point for pretty much every single nitrogen fertilizer on the entire planet. So now we have our ammonia, which acts as a base. How do we turn it into a salt that plants can eat? Well, it's a surprisingly simple three-step recipe. You take your base, the ammonia, you pick an acid, and then you do a classic neutralization reaction to create a salt that is, you guessed it, soluble in water. So what does that look like? Well, if you react ammonia with nitric acid, you get ammonium nitrate, a fertilizer that is packed with nitrogen. Or react it with sulfuric acid, and you get ammonium sulfate. Both are perfect, water-soluble salts that deliver that critical N right to the plant's doorstep, or root step.
All right, so that takes care of the N. But what about the P and the K?
Well, for those, we have to start digging. Getting potassium is actually pretty straightforward. We mine salts like potassium chloride straight out of the earth, and because they're already soluble, they're basically ready to use. Phosphorus, on the other hand, that's a whole other story. We mine it as phosphate rock, which is completely insoluble. And remember our number one rule? In that form, it's totally useless to a plant.
And this is where the chemists get to work their magic again. By taking that useless, insoluble rock and reacting it with different acids, like sulfuric or phosphoric acid, we can convert it into soluble phosphate compounds. This is how we get valuable fertilizers like single or triple superphosphate, finally unlocking that P for the plant.
So, we've covered how to make these fertilizers, but there's a huge mistake people make when using them that can undo all that amazing chemistry. And this is a big one, especially if you're studying for an exam. Pay attention to this. Okay, here's the crucial point. Never, ever add an alkali like lime to your ammonia-based fertilizers. Why not? Because it triggers what's called a displacement reaction. The alkali literally kicks the ammonia out of the salt, and it just escapes into the air as ammonia gas. This equation shows you exactly what's happening. All that incredible work from the Haber process is just gone, wasted, and your nitrogen is lost to the air.
So if you only remember two things from all of this, make it these. First, for fertilizer to work, it absolutely has to be soluble in water.
Solubility is everything. And second, keep your alkalis, like lime, far, far away from your ammonium salts, or you're just going to end up fertilizing the atmosphere